Welcome to the M machine. What does this contraption do? Well, let's see. Let's move around these points here. You got 2 times 6, and what is the result? Let's see if I can get that on the 6. Yep, and the result is what? 12. My goodness. Does it work with whatever number we choose? What about 2 times 2? Well, that's 4. What about 2 times a half? Well, that's 1, isn't it? Yep, looks like it's getting there. So how is this working? 2 times 10 is 20. Does it work with other numbers besides 2? 2, I think we might be getting off the page. 4 times, let's see, 4 times 8. Nope, that ain't gonna fit. 4 times 6 is 24, that works. What's going on? Let's see, these hints tell us. Has something to do with this blue triangle and this red triangle. Well, now what do we see? That they are similar triangles. That means that their sides must be proportionate. And here's the explanation. Both the small triangle and the large triangle have a right angle, and they share an angle. Therefore, they have two congruent angles and are thus similar triangles by angle-angle similarity. The quadrilateral constructed as a rectangle and therefore has congruent opposite sides. Since the triangles are similar, their corresponding sides are proportional. So the horizontal side of the small triangle is to the horizontal side of the large triangle, just as the vertical side of the small triangle is to the vertical side of the large triangle. Note that the vertical side of the small triangle is always 1. See, that's one of the constraints here, is that this is always 1. No matter where we put it, this one's always 1. So now we can use some substitution. The horizontal side of the small triangle is to the horizontal side of the large triangle, just as 1, which we already know, is to the left vertical side of the rectangle. That's this one. And that was the same as this one, remember. Thus, the horizontal side of the small triangle times the vertical side of the rectangle left vertical side, that is, equals the right vertical side of the rectangle. So there you go. That's what we get. And that is what's going on with the M machine. And this is really just kind of a cool way to visualize geometrically multiplication.